Okay, this section is about solving quadratics using graphs and tables. We'll be using your calculator a lot this section, so please have your calculator ready. Start with, think about the following equations. Which ones do you think are quadratic equations and which ones do you think are not? And then we'll define quadratic equation after you've thought about it a minute. Please pause the video and then we'll talk about the solution after you've thought about it. I hope that you answered that number 1 and number 3 are quadratic equations. The definition of quadratic equation is a quadratic function equal to a value. In order to be an equation, it needs to have an equal sign. In order to be a quadratic, the degree has to be 2. So number 2 is not a quadratic because that's a degree 3. Number 4 is linear, so that's not a quadratic either. All right, I want you to think about this. The path of a golf ball hit from the ground resembles the shape of a parabola. What point represents the golf ball before it is hit off the ground? What point represents the golf ball when it lands on the ground? And how are those 2 points related? So after you've thought about it, go ahead and unpause the video and then come back. So this point right here on the graph represents when the ball is hit by the golf club. Over here, this point represents the point at which the ball hits the ground. What those 2 points have in common is that they both have a height of 0. The golf ball starts on the ground and it lands on the ground again, so it has a height of 0. Those are called the zeros of the parabola, where the height is equal to 0. Okay, we're going to do example 1. Example 1 says find the solutions to x squared minus 16 equals 0, which is a quadratic equation. We are going to start by graphing the quadratic function, even though we can't graph the equation. We're not able to graph that equals 0 part. We're going to graph the function. So go ahead and grab your graphing calculator. We're going to graph that function. So x squared, x is next to the alpha key, squared minus 16. When I hit graph, a whole bunch of my parabola is below my screen. Remember, you can always change your window. Right now I'm looking out the window and I don't see the whole parabola. The problem with my window is that the bottom is cut off. So if I would like to see the whole parabola, I need to change my Y min so that the bottom is not cut off anymore. Okay, now I can see the whole parabola. It looks like it has a y-intercept of negative 16. And so that's the parabola. On my calculator, this is how I find the places where this parabola is equal to 0. The parabola is equal to 0 when it crosses the x-axis. So for the calculator to find that place, we hit second trace to get the calc menu. We want the calculate menu. We're going to choose 0 from our list of options. And then it wants me to click, I need to give it a boundary, and I want it to be to the left of where the 0 is. So there's a 0 here and a 0 here. So I need to move my boundary point so that it's somewhere to the left of the first 0. Once I get to the left of that first 0, I click, and then I move so that now it's asking for the right bound. So now I'm going to move my cursor until it's to the right of the 0. I'm going to hit enter and see how there are 2 dotted lines. I want to make sure that my 0 is in between those 2 dotted lines. It is. Now it tells me to guess. You don't have to guess. You can try. You can put your cursor as close to the 0 as you think you can get, but you don't have to. You can just hit enter and it'll tell you. So the first zero of this function happens at x equals -4. So remember, our function is x squared minus 16. We're finding that one of the zeros happens at x equals -4. It looks to me like this other zero happens at x equals +4. The steps again to find that would be second calc 0. I want to make sure that I'm to the left of that 0, so I'm going to get close to it, but I'm not going to pass it. I want to be to the left of that 0. Oops, passed. So then I hit enter. Then I move so that I'm to the right of the 0 or above the 0, and then I hit enter, and then it says to make a guess, but you don't have to, you can just hit enter. And there's the other 0. The other 0 happens at x equals 4, which makes sense. 4 squared is 16, 16 minus 16 is 0. So the solutions to this equation, according to our calculator, are x equals -4, because that was one of the zeros, and x equals +4, because that was the other one. Those are the two places where that function is equal to 0. If you had a graph given to you and you didn't have to use your calculator and you're looking for those solutions, you're looking for where the graph crosses the x-axis. So you're looking for those points where it crosses the x-axis. The solutions of a quadratic equation are the value or values that make the equation true. So x equals -4 makes the equation equal to 0. X equals +4 also makes the equation equal to 0. So just a definition, solutions to an equation of the form f of x equals 0 are called the zeros of a function. The zeros correspond to the x-intercepts of the function. So if you have an equation equal to 0, the solutions are the zeros of the function, and those are also the x-intercepts on the graph. I'm going to have a couple of examples here. These two examples are a little different from the one that we just did, because what I notice is that they're not equal to 0. So you need to, before you grab your grapher, you need to do the math to make sure that you have equal to 0. So if I look at this first equation, it's not equal to 0, it's equal to -49. In order to make it equal to 0, I need to add 49 to both sides of the equation. I'm going to add 49 to both sides. Remember the railroad track from middle school. On the left-hand side, I have x squared. I have minus 14x, and then I have plus 49, but there aren't any like terms, so I just write them all next to each other. On the right side of the equation, I have 0. Now I can grab my machine and I can graph that. I want to point out, though, that we learned last chapter, the y-intercept is going to be 49 on this equation. So my window is going to have to be tall enough that I can see a y-intercept of 49. Okay, so I'm going to type that in. It is x squared minus 14x plus 49. And I might change my window. Actually, it turns out that I don't need to see the y-intercept, but the other thing you can always do is you can do a zoom standard to get your window back to the way it usually is, the basic way. Okay, second calc will help me find the 0. And then it wants the left bound. I'm way off the graph. I can't even see it, so I'm going to arrow over. There you go. So now I'm to the left of the 0. I can click enter. And then I want to move so that I'm to the right of the 0. Okay, now I'm to the right of it. I hit enter. And now if I hit enter again, it'll tell me this one has a 0 of 6.999997. I'm going to basically call that 7. So the 0 happens at x equals 7 and y equals 0. So the solution, and there's only one, is x equals 7. Terrible 7. The reason that it's only one solution is because that's the vertex. So the vertex is touching the x-axis at x equals 7. Okay, the other one, I can't graph it yet because it's not equal to 0, so I first have to add 3x to make sure that it's equal to 0 before I can start. So I'm going to add 3x. I have x squared plus 3x plus 7 equals 0. Now I'm going to grab my calculator and graph that related function. So I have y equals x squared, oops, again, x squared plus 3x plus 7. Graph that. And now this function is an upward-facing parabola, but the vertex is above the x-axis, so this one never crosses the x-axis. There is no solution to this because there's no x-coordinate that would make this equal to 0. So for some of these problems, you're going to have no solution. If you can't find a place where that crosses the x-axis, then you have no solution. It is possible for your quadratic equation to have 0 solutions. It is possible for it to have one solution. We saw that with this problem, where we had one solution, x equals 7. The vertex was on the x-axis. Possible for my quadratic equation to have 2 solutions. We saw that with this problem, where it crossed the x-axis twice. So we had 2 different solutions to the problem. I'm going to pause the video here. I want you to try these problems. So the video will stop. I'll have the answers below. So please try these using your calculator and then take a look at the answers below.